Hi, everyone, and welcome to Covalent Bonding. All right, let me get the PowerPoint going here so we can get covalent bonding started for you. And what we want to do today is talk about covalent bonding, which is all about sharing, because as we all know, sharing is truly caring. So, unlike the horrible pirate world of ionic bonding, well, with covalent bonding, we're going to talk about sharing electrons. So the atoms are working together to share because what better to do than share, like sharing your soda, sharing carrots, even sharing milk. I mean, everybody can share. So why not practice that, right? And make the world a little bit nicer place. So we've got sharing here, sharing there, sharing everywhere, sharing all the time. Sharing is truly caring, right? And so some of the atoms do care enough to share. So that's what we're getting into here. So there are tons and tons of examples about these, but basically what we're going to talk about is what's called the covalent bond. A covalent bond are just atoms that share their electrons. So unlike the ionic bonding, where basically there's a larger atom and a smaller atom, the bigger atom literally takes away the electron from the smaller atom, right? For it because it's trying to complete its octet or its outer electron shell, filling up to 8, right? That makes this one negative, the bigger one, and the smaller one positive. So then opposites attract is what we talked about with ionic bonding. In covalent bonding, it's more like sharing. It's more along the lines of let's get together and just share the electrons from each other. So one electron is not being pulled from one element to the other element, right? So much as they're just kind of more coming together to share the electrons naturally, right? And so just like ionic bonding, there are tons and tons of examples. For covalent bonding, same thing, tons and tons of examples of, well, sharing going on here and everything, right? So one example we could do is this one right here, CH4, also known as methane, also known as, well, other things and everything, right? But it's a great example of a covalent bond, right? You've got carbon in the middle. Carbon, maybe you remember from ionic bonding, it has 4 different electrons to it. Hydrogen only has 1, but they come together and they share. And what happens with covalent bonding is now the carbon has 8 electrons, so it's very happy. Remember, hydrogen and helium are the only 2 elements where they're only looking really to get 2 electrons because they're so tiny. The 2 electrons act like the 8 that normally elements want to have. And so each one of these hydrogens are they're all very, very happy with each other. So covalent bonding means you're sharing electrons. And if you have elements that are bonded together, sharing those electrons, they're known as a molecule, right? So covalent bonded elements are known as a molecule. Whether it's as simple as H2, right? H2 or 2 hydrogens bonded together. Well, now each one hydrogen had its own individual electron. When they come together, they have 2. They're very, very happy, right? So that would be an example for a molecule right there. Okay, we have the early chemist discovering dirt. It's just going to be funny. Covalent bonding, but here's what we want to get into is, okay, we know that covalent bonding means sharing. We know that ionic bonding means basically stealing or taking the electrons from one another. So how do you tell the difference, right? The big thing as far as difference goes is with ionic bonding, at least one of the materials involved is a metal, right? So at least one thing is a metal. If you remember all the examples for ionic bonding that I gave you as far as foods that you eat, all of them have at least one metal inside of them. Covalent bonding, right, has no metals, right? They're all non-metals when they're getting together and everything, right? So they're sharing. So here's covalent bonding, sharing. Here's ionic bonding, stealing from each other. Now the net result is the 2 of them still come together, right? But with covalent bonding, they're sharing with each other. Now, because there's not stealing going on with covalent bonding, it's a much gentler way of coming together, right? So a covalent bond is actually fairly easy to rip apart, whereas ionic bonds, not that you can't break them apart, but they're very, very hard to break apart. It's a very, very strong bond when you have an ionic bond. So ionic bonding, at least one metal combined with at least one nonmetal. Covalent bonds, either one is nonmetal. The only exception is sometimes you can have a metalloid, which this goes way back to the first chapter of chemistry. But for the metalloids, right? Remember, aside from hydrogen, all the stuff over on this side of the periodic table, these are all metals, right? Over on this side, you have the nonmetals. But look, right in here, you've got this one little kind of section. It's like a section of transition metals that are right here. those are known as the metalloids, right? So these metals right in here are metalloids. I guess they're not really technically metals, right? They're elements where they seem like they have some properties of the metals, they have some properties of the non-metals, right? So silicon was an example we've used before, right? It conducts electricity like metals sometimes, but other times, like the non-metals, it doesn't conduct electricity. Boron, for an example, right? It looks like a metal if you see it, but if you smack it with a hammer, it's very brittle. It'll break apart, kind of like some of the non-metals over there. So, but you can have non-metal or metalloids in a covalent bond for it. Let's see here. So it's time to play. Is it covalent or is it ionic is what we want to get into, right? So let's say this one right here. We've got HVO S, right, for it. Which one do you think it is? Is it an ionic bond or is it a covalent bond for it? Well, it turns out V is for vanadium. If you remember again from our first chapter that we had going on there, vanadium is way over here, which makes it ionic. Vanadium is a metal. How about this one right here? For this entire big molecule right here, covalent or ionic? What do you think? Well, as you look at it, well, I can't see any metals in there, so that's going to make it covalent. How about this guy right here? Well, there's a lot of stuff right there. Covalent or ionic? This one's got RH right there, rhodium, and rhodium is over here on the periodic table. It's definitely a metal, which makes this ionic. Another one coming up here. Oh, hopefully this one is an easy one because in the great question of it, titanium, which you guys all know is way over here, definitely a metal. That's going to be an ionic bond. Anything with titanium in it is going to be an ionic bond. How about this one right here? What do you think? Are any of those elements metals? Whoa, we've got boron, right? Boron right here is, wow, look at that. Boron right there is going to be one of those metals right in the middle that we talked about for a bit. It's still going to be covalent, even though it has some metallic properties. It's still technically not, it's still technically not a metal right there. So any of the, remember, all those ones right in the middle, they still count as covalent. How about this guy right here? All kinds of elements in there. Are any of them a metal? Yes, they are. Tungsten right here. Yes, tungsten is over here on the periodic table. Definitely a metal, making this ionic. So hopefully you've enjoyed playing. Is it ionic or covalent? As quickly as I could get through that for us. So you want to make sure that you're sharing, hence our picture right here and everything. Sharing is caring, remember. And after you're done with this, you can take that short little quiz and you should be good for ionic and covalent bonding.